All right, so in the previous video, I just finished up talking about that relationship. So remember, I talked about this earlier. I said this needs to get on your formula sheet, okay? It's your force due to friction, and actually, bit of a typo there on my part, right? Should be FG. All right, so if you can make that change, please, right there. It's force due to gravity plus or minus the vertical force. Bit of a typo on my part, so I apologize. So here is that same expression, and it's minus because we are decreasing the normal force. So it ends up being Fg minus Fa of y equals ma. So now we can plug in the rest of our numbers. So 200 cos 50 minus 0.3. Force due to gravity, so that's mass times acceleration. So that's 65 times 10 minus your Fay. So that is 200 cos 50. Oh, sine, sorry, because it's a vertical component. Sine 50 bracket equals 65 times your acceleration. So using your calculator, we get the 200 cos 50 reduces to 128.6. And then inside the brackets, it gets to 496.8. So now collecting that together, the 128.6 minus 0.3 multiplied by 0.3 multiplied by 496.8 bracket equals negative 20.44 equals 65 times acceleration. Divides both sides by 65. And what we end up with is negative, so acceleration is negative 0.31 or meters per second squared, and my direction originally was right. So let's talk about this. So that means that we assumed the acceleration was going to be right, and that negative tells us that we're wrong. It's actually to the left. When we go back to the situation, is that possible? Force of friction cannot be the driving force. So if our acceleration is negative, so therefore acceleration says they should move left, move left. However, friction cannot be driving force. So what does that mean? And hopefully some of you are saying, well, up here it was a dead giveaway at this point right here, because the difference, our Fu up here, our unbalanced force, was actually to the left because it was negative, which means force of friction is greater than the applied force. So what that means is therefore Matt is not pulling hard enough to move them. So they will not move hard enough to move Tristan. So in fact, there is no motion here. So therefore, the question was asking about acceleration. The acceleration is 0 meters per second squared. No one's going anywhere, no one's moving. So again, physics, it's notorious. Negative answers are not inadmissible all the time. They require interpretation. So here's a perfect example. So Tristan not pulling hard, or Matt was not pulling hard enough to move Tristan. Still means no motion, which means acceleration is actually 0, not the negative 0.3. All right, so push lawnmower has a handle at 50 degrees above the horizontal. If the coefficient of kinetic friction is 0.85 and the mass of the lawnmower is 40 kilograms, determine at which force you must push to maintain uniform motion. So, free body diagram. Here's the lawnmower. I'm going to push on it at an angle of, I like 50 degrees apparently, 50 degrees. I don't know what my applied force is. All right, so it's Fa. I know my coefficient of friction is 0.85, that's kinetic. Mass of the lawnmower is 40 kilograms. 40 kilograms. determine at which force to maintain uniform motion. Uniform motion is very important because with uniform motion, that means that my applied force has to equal my frictional force. All right, all forces in the horizontal will have to be balanced. So let's finish putting my forces on my free body diagram. So there will be FAX. Now the Y component will be pushing down. So you are technically pushing down on this lawnmower. So my Y component is there, but I also have force due to gravity. So we're actually pushing down on this lawnmower. So if there was a scale underneath, it would have a greater mass or greater weight because you're pushing downward. We have a normal force, and then we'll have our frictional force. So we want to make sure that the unbalanced force here is 0. So when we go and do our calculations here, we want F unbalanced to equal 0. All right, so that's where we're starting. Unbalanced force is 0 because whatever you're pushing with has to have a constant velocity. We can't have an unbalanced force. What's our unbalanced force? Well, say FAX minus force due to friction, and it has to be equal to 0. What is FAX? Well, that's our horizontal component. So it's going to be the magnitude of FA. I don't know that. Cos of 50. Actually, let's just go cos theta for the moment. Minus force of friction is mu, and it is your force due to gravity plus or minus your FAY. Now you're pushing down on the lawnmower. FAY is going in the same direction as FG, so you're going to add them together. So the normal force is that sum of FAY and FG. That being said, we can now do some more substitution. I don't know FA, so it's going to stay FA. I know the angle is cos 50, so I can substitute that. I know this has to be 0.85. That was given. Force due to gravity we can calculate. That is 40 times 10 plus FAY. Well, that's the magnitude of your applied force, which we don't know, sine 50. And that's equal to 0. So what you're going to have to do is you're going to have to get the FAs together, those values, group them together. All right. So I'm going to leave it in its form here. I'm not going to get the calculator out. You can definitely calculate and get rid of the functions if you want. But getting rid of my brackets and stuff, I'm going to have, well, I'm going to do distributive law. So I got to multiply that negative 0.85 into those brackets. So using the calculator, 0.85 times, it's going to be 400. So it's going to be negative 340. And then it'll be minus 0.85 FA sine of 50. That's equal to 0. So now I have rid of all my brackets. I'm going to skip a step here, so you got to pay attention. I'm going to add 340 to both sides. All right, that's my first step. So my next line will be 340. Now my remaining two terms have an FA in them. So I'm going to common factor out that FA. All right, so that would leave me with cos 50 minus 0.85 sine 50. All right, which means that I would have to divide both sides by what's in the bracket there. So cos 50 minus 0.85 sine 50. Same thing over there. Cos 50 minus 0.85 sine 50. Those would cancel out. And now it's just a matter of doing the calculations. So that isolates the magnitude of the force, and that's all we're looking for. So the 340, and we're going to divide that by cos 50 minus 0.85 sine 50. And we get, let me try that again. And I double check the calculator, and I end up, if you calculate that, that's negative 40,717 15.7 newtons. To the right, now I got a negative answer. So that doesn't really doesn't answer our question, I guess. I was hoping to have one question work out to be a nice answer, but now we get to work on interpretation once more. So what does this mean? So because it's a negative answer and it means that it's opposite to the situation I showed there, it tells me that there is no way in order to push this lawnmower to achieve this. So therefore, not possible to push at a constant speed. So the ones in the textbook don't work out like this. I just wanted to show you worst case scenarios, and apparently I'm going to do it back to back here. So it's not possible to push at a constant velocity. All right, we need to come out with a positive value there. So unless I made some math mistake that I don't see immediately, that looks to be what our solution is here. All right, so the negative does indicate we could likely pull it and achieve that with the 40,000 newtons. All right. Okay, on to the next one. So Captain Monteith's spaceship is currently traveling at a constant velocity through space. Suddenly he's attacked by the evil Parkers. To defend himself, she fires 2 rockets. One rocket is launched with that force. The second rocket applies that force to the ship. So if his spaceship, and I jump back and forth on gender here just to make the question far more challenging than it is. If his spaceship has a mass of 10 times 10 to the 6 kilograms, determine the vector acceleration it will experience. So in space, the spaceship is braced against nothing. There's no friction. So when you launch objects from it, that propulsion, the rocket really kicks off from the ship, and that's what creates that change in space here. So the first one rocket goes out east, 30 degrees south. So that means that there is a force applied in that direction. And that is the 2,000 newtons. So I'm going to draw myself XY axes, 30 degrees, and that was 2,000 newtons. Second rocket then is shot north 45 west. So there's my 45. And we'll call that force B, and it is 1,500 newtons. And we know the mass of the spaceship is 10 times 10 to the 6th kilograms. So we know that the resulting motion of our ship is going to be the resultant of those 2 forces as it pushes or kicks away. So our resultant, going back to what we already know about vectors, is the resultant is equal to your first force, force A, plus force B. So we can set it up in our stacked notation that these 2 forces are going to provide a resultant force. So we have the first force, positive x direction, so 2,000 cos 30I, minus, it's going negative y, so it'd be 2,000 sine 30j. Second one has a negative x component, that's the 1,500 cos 45I, plus, because it is a positive y component, your 1,500 sine 45j. And now we can do our stacked addition. So we find that the resultant has 671.4 newtons in the I direction, 60.7 in the J direction. From that information, we can then find the magnitude of our resultant. So it is the square root of those 2 options squared, and sum of them squared. So we find the resulting force is 674 newtons. Our direction, theta, is tan inverse of 60.7 over 671.4, which gives us 5 degrees. So therefore, resultant is, and we can finish that off. We've got one last video I need to finish up, and then this unit, or this particular section, is complete. So I'll finish this statement up, and we'll finish in the next video.